Hi everyone, welcome back. And this is the second part of making 2D self-driving simulation. So we are not going to delay anymore. What steps we need to follow? The very first thing, you will open your Replit over here. So this is your Replit, and when you log into the Replit, you can log in by using your Google account. You can go with create REPL, and over here you will select pygame. If the pygame option is not coming, you can type pygame and you can easily select pygame. Here you are going to write self-driving car simulation. So this is my project name and I'm going to click on create REPL. So when I'm going to do this, it will create a REPL for me. If I'll explain you the REPL, over here you are going to write down the code. Over here you can get your files and over here you can get your output. It will take little time to load. So this is the basic command of showing the display like I told you in the car movement project. So if you will show, like run this code, it will show you the very basic display that will be the parameter of the X will be this and Y will be this. And the caption will be hello world. The title you can see it's hello world. It's a black color screen, the blank screen basically. And when you click on cross, you can exit the screen. So this is what command given over here, that import pygame sys. Okay, let me introduce you about sys, what sys library is and what sys is going to do. So sys is actually a library which is help us to run the Python environment in the actual time. So it will make your code running will be very faster. So such commands we can handle with sys, like command line argument, exiting the script, standard input output, handling recursion limits, assessing the Python version. So these things you can simply handle with a sys. So that's why you are taking sys over here. After taking the sys, you can have this pygame local, because you need to take pygame for making the 2D environment of that particular game. You need to initialize your screen. Here you are setting up the environment of your screen. Here you are writing down the code, hello world. Here is the loop. This is actually the main loop when you are dealing with pygame. So this all thing you already know. How are you going to, do the setup for this? So I'm simply going to remove this and I will do the basic setup for my code environment. So I'm actually, the code is very big. I'm not going to waste the time of yours. You can simply pause the video and do a write up of code. I can simply have the code already. So I'm just showing you what are the initial steps we need to follow. Over here, what I did, I simply made some parameters that I required for my game. I did import sys, import math, because these two things we need, these four things we need. Neat, I already explained you why are you using neat. If you don't know, you can go to the previous video. You can simply see like what is this and how we can do this. So these are actually the library import. Basically, when you want something to import, you can easily do that. Okay. So if I want some other module or some other piece of code over here, so I can easily get that particular part, right? The same thing I can see over here. Here I'm initiating the screen. So this is how I'm initiating it. Over here, it's saying the caption self-driving car. The window size I'm setting up 700 to 720, but no, I will be setting it up So this is a width. Actually, my picture width will be more. So I'm setting it up with 900 to 720. It's fine. The screen, I'm actually setting up the mode of the screen. The card size, I'm setting up the parameter of the card. Like I will have the picture of card. So you need to set up the X and Y for the card. So 30 is the X and 51 is the, sorry, width and height. So 30 is the width and 51 is the height. Card center, actually you need to set the center of the card, like where uh, is the track and where your card should have the position. So this is the X and Y coordinate we are giving. Delta distance, because it has to maintain a particular distance. So I'm just taking it 30. Delta angle, because it has to make an angle. That's why it's 10. The color is white. Then there is a track.png. Right now I'm not having it. So what I'm going to do, I will simply take all the file import. You will go to these three dots and you click on upload files. When you do upload files, you will get your files. So I want a picture. I want the configuration of card. So I'm going to select these four things and I'm just click on open. So I got something. I will delete this Redmi file. I'm not taking this one. So I have the car picture. This is my car picture that I want. And this is the configuration text file, as I told you already, that for need library to execute, I need the configuration one. This is my code that I'm performing. I need more files. I need one track also. So I'm getting my track and I think it's enough. Yeah. So the resources I have. So I have track.png right now and I can see that track.png over here. Track.copy is actually, I'm copying the picture over here. Here I'm setting up the font. Here I'm setting up the clock, and obviously I made a variable with name generation, and we could call the generation from generation 0, right? So it's supposed to change generation by generation. So that's why it's going to change generation by generation. So this is the first part we did. Now, what are the next steps that we are going to do? We will actually define the functions, the various functions, and according to the function, we will work with our program. So the next step that we need to define is actually we are going to define the function over here, and the function that we'll have is translate point, angle, and distance. What happens is, suppose we are having a track. This is our track. Okay. Now in our track, what we'll do is that this is our car, and my car will automatically take turns and it will detect and it will go forward. So how do I know that that this point is correct and how much turn my car is going to take, or how much translate the angle according to the car? So this function is actually indicate that how my car will translate to the particular angle. So the point we have in a tuple, that is xy, and this xy will represent the coordinate of the point. Means we can say that the center of the car in your simulation. So I'm simply going to write down this code as well. See, the code of this is very long, so that's why I'm just doing it in short. You can simply pause your video and you can do write down the code. I'm just clear out your doubts and let you understand the concept of behind this self-driving car simulation. So as you can see that there is a lot of mathematics included, that there I can see that there is a radian is equals to math dot radians angle. So what actually it is? What angle is? Angle is the angle of rotation in degrees from the horizontal point of x-axis. Of course, we are calling it as x-axis point, that determine the direction of which the point will move, right? Where my point is actually going to move. And distance is the point that you should move directly specified by an angle. Now, what is the logic behind this function? Number one is that it is converting the angle to radians. Okay, what it is doing? The angle, it's converting to radians. So a conversion of angles from the degree to radians because of that trigonometric function in the Python. The Python has math.cos, math.sin. So these are the trigonometric functions. So we are working with the radians right now for making it more accurate, because it radians, when we calculate the coordinates, it is helpful, right? So if we are calculating the coordinate, so the x coordinate will be like x plus distance multiplication of cos angle in radians. Now, for the y, we can say that y plus distance multiplication of sine angle and radian. So there is a little mathematical concept. If you are clear about maths, then you can easily understand this thing. Now we are going to return the new coordinate. So suppose, for example, if you are having a new point, I can say that the translate point is between 100 and 45 degree is the angle, and 50 unit it has to move, right? So if I'm going to print the new point, I can find that the output of the coordinate will be 135, 135. So automatically it's actually taking the angle, it's actually taking the steps that we are supposed to move, or we are supposed to do forward. Now afterwards, we are having one class. Okay, what class is? Class is actually the combination of number of functions inside it. Means if there are a lot of functions, so what we will do, we will simply combine all these functions. We are putting all these functions inside one class. Okay, because this method is actually easier to call and easy to access as well. So if I will go to the next part of the code, I will make a class. Now, what the class is and why is it coming in point? Okay. So my class name is car, right? So this car class is actually containing a lot of things. What things it has? So this car class handles a lot of functions like the car movement, car rotation, collision detection, sensor data updates. So these all things my class car is actually taking. So what key methods actually we are using over here? We are using one key method that is display underscore car. So display underscore car method is actually rotate my car on the screen. Okay. So if I'm talking about this method, it will rotate my car on the screen. Basically, when we are making one class, we are having one method also for a common class, that is init self. Init self is actually, I can say that whenever I'm calling my class, I should make an object first and then I will call the class. So this init self, we are defining all the function variables inside. So this is one of the method when we are making the class. Okay. So I'm making a function define init self. Over here, I made define init self. Now, everything, every variable if I'm assigning, or everything if I'm assigning for any function, I will always use this self parameter, because this is actually connecting to the class. At the end, when I'm calling my class, I can directly call this in itself as an object. Okay. So this is important. So I'm saying self.corner, I'm making empty list. I'm actually making 3 empty lists for edge point, edge distance, corners, travel distance. So basically there are a lot of parameters only. Now self.car, I'm actually loading the picture, whatever the picture I had. And because we need to scale the picture as well. So I need to transfer the scale. The car crash right now is false. And every time in pygame, you know that we need to update the screen. Okay. So when we are doing this, we have to update the screen. Now we will have a lot of functions over here to do that. So the first function that I will have is to display the car, right? Like we have to display the car, we have to crash check whether my car is crashed or not. Okay, so these are the function that's important for checking. So let me give the proper indentation and I will paste the code. Okay, so here is this is the actually the multi-line comment we will do, and we can always use it without space like this way. This is not fine actually. If I'm doing it this for all, then it will be fine. No, it's not fine. Okay, no problem. I'll just remove the comments. So I'm removing this comment also. I'm removing this comment also. You don't need to write down the comment unnecessarily or making it lengthy. So yeah, the next part is after defining the init function and you are having self. Now every time, everywhere you can see that whenever I'm calling the parameter is self. Why? Because I made the very one basic common function that is initiate one inside the class, and now I can initiate any function with these parameters. Okay, so display.car is actually help us to rotate, like to rotate the car as you can see over here. Okay. Now next is crash check. What is crash check? Crash check is checking if the car has gone off the track by looking at its coordinates. Okay. Like if my car will strike to the corner, then it will go out of the track. So that's what we are doing in crash check. So, rotated car equals to pygame dot transfer dot rotate self car self angle. Of course, it will rotate with two parameters. Then, rect is equals to, of course, when you are making a car, you should have to make a one platform that you will have to call it as rect. Now screen dot blit, and you have to paste that picture onto the screen as well. So we are using screen dot blit command, and we are just giving the position that where are you going to blit this car. After that, I told you that crash check is actually checking whether my car is, you know, collide with the edge or not. So crash check self for corner in self corner if track dot get corner equals to white color, return true, return false. Basically, it says that because my background is white and my track is black, so if it is getting the track corner a white color, so it will crash. If it is not, it will run. Very simple criteria we are using over here. So I think for today's session, it's enough. You can pause your video, you can write down the code, and in the next session, we will be writing down more code. Actually, we are not writing because it's very lengthy code. I don't want your time to waste. You can easily pause the video and do write down the code. I'm actually explaining you the concept how you can do 2D simulation with this. So I hope it's all clear, and we will meet now in the next session. Bye bye.